Hello, everyone, and welcome back. Today we are going to be talking about the cosine law. So, there are two formulas for the cosine law. The first one is used to find a side, and the second one is used to find an angle. Now, there's only a couple situations where we would use the cosine law, and I'll talk about why that is in a little bit. But first, I want to address something here. With the specifically with the cosine law, it is important that we stay consistent, just like with the sine law previously, right? If we are trying to find a squared, then we need angle A. B and C can be either of the other two, but the A squared must be consistent with the angle that we are using. It's very important. And then, as you can see, the second cosine law is really just the same thing, but the difference is that we have just rearranged it automatically in order to find the angle a little bit easier, right? So that's the goal there. It's really the same equation twice. However, it's just a little bit harder and a few more steps to actually do this ourselves. So a lot of people prefer to just use these two different ones, right? To use this formula if we need to find a side, which we're looking for side A specifically, or this one if we're using it to find an angle. Okay, so something I want to review from the last one though is how this is going to work. Let's say we have a triangle. I'm just going to draw a random triangle here. And let's say our triangle we're going to label A, B, C. Remember that side A is opposite to angle A, side B is opposite to angle B, and side C is opposite to angle C. That's very important. And I want to also be clear that this isn't just used to find angle A. We can swap these things around, right? We could use this formula to find angle B and say B squared is equal to A squared plus C squared minus 2 AC cosine of B. But if we switch these things around, if I want to find B squared now, then I must use angle B. I need to be consistent here. And then I must use A and C as my other two sides, right? And same thing goes with over here. So as long as we're consistent, we're good to go. This just shows it specifically for finding side A and angle A, but we can generalize this to any side so long as we stick with the consistency and ensure that this angle we're using is the same, corresponds with the same letter as the side as well, is very important. So let's talk about the two scenarios where we will use cosine law. And I want to be clear that the reason we're only using these two is not because these are the only two where it'll work. Cosine law will always work for any triangle, right? We could use cosine law instead of basic trig ratios. Now, I don't know why we would want to, because cosine law is much more complex than basic trig ratios, so we probably wouldn't want to do that. We could also use cosine law instead of using sine law. But again, sine law, even though it's more complex than basic trig ratios, it's more complicated. It's still a lot less complicated than this cosine law. So I don't know why we would want to use it. So we're only actually going to want to use it in these two cases where we cannot use basic trig ratios and where we cannot use sine law. Now let's talk about why we wouldn't be able to use basic trig ratios. Why would we have to use cosine law? Well, because cosine law, as a reminder, and sine law as well, actually, for that matter, they work for all triangles. Basic trig ratios only work for right angle triangles. So if we have a triangle that is not right angle, or if we're not sure if the triangle is a right angle triangle or a not right angle triangle, then we must choose sine law or cosine law. So we cannot use basic trig ratios ever in those cases. It will most likely not get us the correct answer unless our triangle happens to be a right angle triangle and we happen to have done everything right with that and made the right assumptions. So it's very rarely ever going to actually work. As for cosine law versus sine law, let's think about when we can't use sine law. We can't use sine law if two sides and a contained angle are given. So for example, if we have something like example 1, the trouble here is that we have this angle and we need to find this side. However, we don't have any other angles to match with this one. So if I try and use C or A, I'm going to have two unknowns, right? So we aren't able to solve it. Now, this does not apply to situations where we have two angles in one side, because in the situations where we have two angles in one side, it's very easy to find the third side, right? In any situation where we have two angles. And so we can find that not third side, the third angle, we can easily find using the fact that all three angles must add up to 180. So this only applies when we have two sides and a contained angle. This does not apply in situations where we have two angles and a contained side, because we can easily find that third angle, and therefore we can just use sine law. And doing that extra small calculation with sine law is still a lot simpler than using cosine law. So that's the first situation, is two sides and a contained angle. The other scenario is three sides, right? Because let's say we knew all three of the sides. We know what A, B, and C are, but we don't know any angles. Well, sine law requires us to know at least one angle, right? So if we don't know any angles, we're going to have two unknowns, right? Well, we'll know the two sides, but we're not going to know the two angles. So we won't be able to use sine law to solve. So those are the only two scenarios where we have to use cosine law to solve. In every other scenario, we can just use sine law, or even in the worst case scenario, we might have to do one extra quick calculation, to find one last angle in order to then apply the sine law. And so these are the only two situations where we must use cosine law. Now, again, that said, we can use cosine law whenever we want for any triangle, and it will always work. It's just that it will take a longer time and will not be the most convenient strategy to use. But it will work. It will get you the right answer, I will say that. Okay, so let's use the cosine law to solve this one here. So first, let's talk about what we're given. So we're given angle B. We're also given sides A and C, and we're asked to find the unknown. We're asked to find side B. So what I'm going to do is, since we're being asked to find a side, I'm going to use the first formula here as opposed to the second formula. The first formula states that a squared, which in this case is going to be b squared, because that's what we're looking to find, is equal to a squared plus c squared minus 2ac cosine angle b. So notice how I did change around my variables, but I was consistent, right? This b squared and this b are the same, and I also kept a and c the same and consistent here. So I switched around my variables, but I was consistent. So you are able to switch around the variables so long as you are consistent with it. Okay, so b squared, we don't know what that is, equals to 12 squared plus 10 squared minus 2, 10, 12 cosine 40. So now what I'm going to do is I'm going to punch that into my calculator. Well, what's cosine of 40 times 2 times 10 times 12 is equal to minus 183.85 approximately, 144 plus 100. So b squared, therefore, is equal to 60.149. And then I'm going to take the square root of both sides. And I'm going to end up with b equals to 7.76. Okay, so that's going to be my final answer. That side b is 7.76. Which, that's interesting, actually. I thought it might be larger than that, but you know what? Maybe this drawing is not is not really, or sorry, I thought it might be larger than that, but you know what? Maybe this drawing is not really to scale. That is a possibility for why we're getting 7.76 rather than a different answer there. So good. So we did it. Okay, let's move on. Let's move on to two more examples that we have before we do the word problems lesson. This one is a little bit different because here they want us to find angle C. So they want us to find this angle. And just a reminder, the angle formula states that angle C is equal to a squared plus b squared minus c squared over 2ac, or ab rather. So let's do that. Cosine of angle C is equal to a squared plus b squared minus c squared over, instead of 2bc, we're going to put 2ab. Okay, so let's plug those in. Cosine of c is equal to 5 squared plus 9 squared minus 8 squared, right, over 2, 5, 9. So what does that equal to? 25 plus 81 minus 64 is 42 over 90. And so now I'm going to second function cosine, right? We want the inverse cosine in order to give us c. So the inverse cosine, 42 divided by 90, is 62.18, which I'm just going to round to the nearest degree and say that it's 62 degrees. And you know what? That seems quite reasonable, that this might be about 62 degrees. So I am happy with that. That sounds good. All right. Next, let's try example 3. Given the following diagram, find the distance across the river. So here, in this case, I'm going to label my points however I would like to. So I guess I will label this A for the boat, and then side A, and then B, and then C. So in this case, we have side, angle, side. So this is more similar, a lot more similar to the very first one that we had. So we know that the cosine, we know that A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. So therefore, A squared is equal to 27 squared plus 30 squared minus 2 times 27 times 30 times cosine of 47 degrees. So let's punch that in the calculator. Cosine of 47 degrees is equal to times 30 times 27 times 2 is equal to 1104.837 approximately. And then 27 squared is 729 plus 30 squared is going to give us 1,629. And that's equal to A squared. So 1,629 minus 1104.837 is equal to 524.163. And if we take the square root of both sides, let's square root that, we get 22.895. Well, that's a lot of decimal points, more than I might normally give, but that is my answer, is that it's going to be 22.895 meters approximately. So therefore, the distance across the river is 22.895 meters. Awesome. All right, well, that is everything for today for cosine law. Next time we'll come back. We are going to do some word problems related to the sine and the cosine law. And then after that, we will begin talking about periodic functions. So I will see everybody back for the next session. Bye, everyone.